All right, so we are going to dive back into our conversation about graphing rational functions. All right, so in our previous lesson, we talked about vertical asymptotes and holes. All right, so in this lesson, we're going to add two more pieces, all right, which is horizontal asymptotes and intercepts. All right, and we're going to try to tie together a few different concepts that we've already talked about. So to get us started today, we're going to do kind of three pieces to our opener here. All right, so here's the first part, opener part A, which is our rational function in HK form. So I would like you to graph that function and then identify all the key pieces here on the left side. So go ahead and pause the video, do that opener. We'll flip it back on and see how you did. All right, so let's see how you did. So if I throw up the work for you here, all right, so we have our vertical asymptote at x equals 4. All right, we have horizontal asymptote at y equals 5. All right, so right there, which creates our new center at 4, 5. All right, and then notice, all right, our a value is 2, so I'm going to go to the right one and up 2. I'm going to go to the left one and down 2, and then I'm going to draw each branch, all right, of our rational function here. So notice, the other thing is this is this is in lowest terms, all right, which means we're not going to have a common factor in the numerator denominator that's going to divide out, so we're not going to have any holes when we're in HK form. All right, and then that means our only domain issue was at x equals 4, so our domain for this problem would be all real numbers except x equals 4. All right, so hopefully you did well on that. Okay, so now let's look at opener part B here. All right, so this dives into what we did in our last, lesson, all right, which is now we have a rational function not in HK form, and this time, all right, I would like you to identify the vertical asymptotes, holes, and what would be our working domain for this particular rational function. So once again, all right, go ahead and pause the video, work that problem, and then we'll see how you did. Okay, so let me throw up the work here. Now, I did not show my work on factoring. All right, so once again, whatever method of factoring you're using, as long as you get what I'm getting, you're good. All right, now if you're struggling with factoring, all right, a lot of what we're going to do over the next few days are going to be very difficult for you. So make sure that you ask questions, you clarify, you come in and get some extra help if you're struggling with factoring. All right, so if I factor my numerator here, x squared minus 1 factors into x plus 1 times x minus 1. If I factor the denominator, x squared minus 3x plus 2, all right, factors into x minus 2 and x minus 1. Now, so notice we have two domain issues here, right? Okay, so with our first factor, we know x cannot be 2. All right, and with our second factor here, we know x can't be 1 because those make the denominator 0. All right, so those are our two issues in our domain. Now notice, we do have a common factor here. All right, and our common factor in the numerator and the denominator is that x minus 1, all right, which divides out. And remember what we said, that creates the whole, right, when we have that common factor in the numerator and denominator. All right, so we're going to have a whole at 1. And then notice in our simplified version here, all right, we're left with x minus 2 in the denominator. All right, and we said whatever's left in that denominator is where our vertical asymptote is going to be. So that's at x equals 2. Now the last piece of the problem, right, is that we said that we have to find the y-coordinate of our hole. And remember, the way we do that is we take 1 and we plug it into this. So if I had done that, I would have had 1 plus 1 over 1 minus 2. And so I would have gotten 2 over negative 1, and that is where the negative 2 came from when I found my hole there. Okay. So hopefully, all right, that clicks based on what we did last time. Now notice, when we did this in HK form, we know where the horizontal asymptote, right? So we can see that it's our k value up here, y equals 5. All right, now, so here's a big part of what we're going to talk about today. How do we find that horizontal asymptote when we're not in HK form? So just kind of think about this. You don't necessarily have to know, so you can pause the video here and think about this for a few minutes. All right, so what do you think the horizontal asymptote would be for this function f of x here? And then how do you know that? All right, now in a few minutes we're going to go through and talk about how we will find that and what we will know, all right, based on that. But just kind of think about that and kind of keep that in the back of your mind. Okay, so that takes care of all of that for now. Okay, so now if we go to the next page, all right, we want to do some investigating, all right, on how do we find that horizontal asymptote. All right, now, so what we're going to do, I'm going to ask you to go through and pause the video here in a second. All right, and then what you're going to do is you're just going to go through and fill out this table of values. You're going to fill out the second, third, and the fourth table value. So you're just going to take negative 1,000, plug it in, get your value here. Take negative 100, plug it in, get your value. And then same thing for negative 10, right? You can use a calculator here. You can go to desmos.com /calculator. All right, that's really easy because you can type in the function. You can click on the gear shift, and you can bring up the table, and you can type these in, and it'll give you the values there. So whichever way you want to. All right, go ahead and pause the video. All right, and fill out all 4 tables here. All right, and then turn the video back on, and we're going to discuss what that means. All right, so I have my tables here, so I'm going to just pull those up real quick. All right, now your numbers may not look exactly like mine depending on how you round it, but I try to go to at least 3 decimal places here to give us an idea. Now, here's what we're thinking about, right? So horizontal asymptotes is what we call in behavior. All right, so it's as we go towards positive infinity or as we go towards negative infinity, which means as x gets really big, what happens to our y values? As x gets really, really small, what happens to our y values? And now when I look at my table here, as x gets really large, so 1, 10, 100, 1,000, look at my values. They're getting closer and closer to 1, right? 1.3, 1.03, 1.003, right? So it looks like as x gets really, really big, my function is getting closer and closer to 1. All right, now as I go to negative infinity, so now as I go this direction, right? Negative 10, negative 100, negative 1,000. Notice here, 0.75, 0.90, 0.997. So it looks like I'm getting closer to 1 this side, but it looks like I'm coming from below, right? Because these numbers are a little bit below 1. All right, so it looks like as I go in either direction, I'm getting closer to 1, maybe from above or below, but that kind of makes sense because we know the shape of that rational function, right? And we've seen that, okay? Now, I'm going to pull up the graph here for us to look at, and so you can see that. So now notice when I look at this function here, all right, you can see that we have the 2 branches like normal. It's coming down and it's getting closer to 1 right here. This side is coming up and it's getting closer to 1. So notice in both of these, all right, on both ends of our graph, we're approaching 1. So we can see that horizontal asymptote, all right, okay, that is going to be 1. All right, so that was the prior problem that we just did all the work on. All right, so now, all right, let's take a look at the next table. All right, now when I look at this, all right, as x gets really big, 1, 10, 100, 1,000, 3.5, 22, 202, 2,002, it looks like it's going to keep growing, right? Those numbers aren't getting closer and closer to 1 number. They're getting bigger and bigger and bigger. So it looks like maybe our function is going to keep getting bigger and bigger and bigger as well. All right, so now let's look at the other end here. All right, negative 16, negative 196, negative 1996, right? It looks like the same thing, right? It looks like as we're going farther and farther to the left, as x is getting smaller and smaller and smaller, y is also getting smaller and smaller and smaller. So it looks like f of x is going to go to negative infinity. All right, so once again, let me throw up the graph here. All right, let me click this one off, and let's click this one on. And you can see that, right? It looks like it's going to keep going up and up and up and up and up and right off the screen there. This is going to keep going down and down and down. Notice we don't get that curve where it flattens out, right? So there is no horizontal asymptote here, right? There's a bend to it, all right? But it doesn't bend and flatten out like we saw in the previous examples or in some of the other rational functions that we've graphed so far this year. So we would say if our function keeps growing in either direction, that there would not exist a horizontal asymptote. All right, so now let's go back to, all right, our tables here. All right, so same thing here. Let's look as x gets bigger, right? 2, 1.5, 1.5, 0, 0, 0, 0, and then my calculator just rounded to 1.5. So it's saying, well, really, when we get out here to 1,000, all right, or above, it's going to pretty much look like our function is 1.5. Now to go the other direction, all right? All right, so when I go this direction, I don't know why I have negatives here. Those aren't negatives, all right? But same thing, but from below, 1.4995, 1.4999. And once I got here, all right, once again, it was like pretty much telling me on my calculator it looks like 1.5, right? So it looks like we have a horizontal asymptote. So once again, I kind of covered up my graph here. Let me pull this up here. All right, we'll turn this one off. We'll turn this one on. All right, and then once again, yeah, you can see that this graph flattens out, right? So we get that nice flat graph. All right, and you can see it looks like it's about 1.5, right? 3 halves there on both sides. All right, So we can see the difference in that second graph, and I'll just put this one up here just so we saw it, right? Okay, we still have two parts of the graph, but we don't get that bend where it flattens out, right? So we can see the difference between having a horizontal asymptote and not having a horizontal asymptote. All right, so let's turn both of these off. Let's go back to our table here. All right, let's look at that final one here. All right, so now, same thing, as I get bigger and bigger, right? 0.02, 0.001, 0.000001, right? I may have had an extra 0 in there, but you guys get the idea, right? It looks like we're getting really close to 0, right? And as I get really small here, notice I have that 0 here, and then I get 0.009, and then 0.000009, and then I'm going to get 0.000. It's going to just keep getting smaller, 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 and it looks like it's going to come back and get really close to 0 there. So once again, this looks like we can have another horizontal asymptote here. So let's take a look at this graph. All right, there we go. All right, so once we get here, right? All right, so now notice, technically, if I kind of go this way, all right, if I zoom in here, technically it starts below and it crosses at -10. You can't really see it, but it's just barely above here. All right, it's barely above, and then it's going to get really close there. So you can see, once again, that when we look at this, we get that really big bend, all right, okay, in our curve, all right, to where we get a horizontal asymptote. All right, so now here's the idea. How do we know when that's going to happen, right? Let's look at some things in our notes here. All right, so if, I'm going to leave that here. I'm going to flip the page and take a look here. All right, so we're going to really have three situations. Let me get the graph out of the way here. All right, so situation one here. All right, and in all three situations, what we're going to be doing is comparing the degree of the numerator to the degree of the denominator. Okay, so if the degree of the numerator is greater than the degree of the denominator, there will be no horizontal asymptote. All right, so now notice, we have a third degree polynomial in the numerator, a second degree polynomial in the denominator. No horizontal asymptote. A second degree polynomial in the numerator, all right, a first degree polynomial in the denominator. The numerator is greater than the denominator. No horizontal asymptote. Okay, so now, once we see that, now let's go back to the example in our table here, right? So let's go back to the second table here, right? And we said there's no horizontal asymptote, right? This is the one that didn't have the bend, right? And notice the degree of the numerator is 2, the degree of the denominator is 1, the degree of the numerator is greater than the denominator, therefore we do not have a horizontal asymptote. So that's situation 1. All right, now situation 2, the degree of the numerator is equal to the degree of the denominator. So what's going to happen here is the horizontal asymptote will be the ratio of the leading coefficients. All right, ratio of the leading coefficients. So if I look right here, we have a second degree over a second degree polynomial. Now remember, the leading coefficient, we have to write it in order, right? So it's got to be in decreasing order of our exponents. All right, so then the ratio of my leading terms would be 4 to 2, all right, which reduces to 2, so my horizontal asymptote would be y equals 2. First degree over first degree, all right, and then so those are the same. And if I look at the ratio of those leading coefficients, that's 5 to 3, so my horizontal asymptote would be y equals 5/3. Okay, now let's tie this back into that exploration we did with those tables, all right, and I'm going to go back here. So notice this is the one we did in opener B here. So notice we have a second degree polynomial over a second degree polynomial. The degrees are the same. So now let's look at the ratio of those leading coefficients. And the ratio of those leading coefficients would be 1 to 1. And what did we say here? Yeah, there's our horizontal asymptote is y equals 1. All right, let's go down to the third one here. H of x here. Notice a third degree polynomial over a third degree polynomial. Same degrees in numerator and denominators. Look at the ratio there, right? 3 to 2, 1.5. All right, so we can see that that showed up in our exploration here. Okay, so if the degrees of the numerator are the same, all right, if the degrees of the numerators are the same, then, all right, we get a horizontal asymptote, and it's the ratio of those leading coefficients. All right, now the third situation here is that the degree of the numerator is less than the degree of the denominator. When this happens, the horizontal asymptote will be 0. All right, and this should make sense if we think about fractions. If the degree of the denominator is bigger than the numerator, the denominator is going to grow at a faster rate than the numerator. And if we have a bigger number in the denominator, right, than the numerator, that means we're going to get a number closer to 0, right? It's going to be less than 1, and it's going to keep approaching 0. so that the denominator is going to outgrow the numerator, which means eventually it's going to start looking like 0. All right, so first degree over second degree. All right, horizontal asymptote is going to be y equals 0. All right, a 0-degree polynomial over a second-degree polynomial, right? So you can kind of see that these denominators are going to outgrow the numerators, right? And we know if the denominator is bigger than the numerator, what happens mathematically? We get y equals 0. Now, if we go back to that exploration, right, we said the horizontal asymptote here was 0. All right, now look at our rational function here, a first degree divided by a third degree, right? That third degree polynomial, that cubic function, is going to outgrow that linear function, right? All right, it's going to take it to 0. And conversely, when we talk about this, that's why we don't get 1 here, right? If the numerator is going to grow faster than the denominator, the numbers are going to get bigger and bigger and bigger. All right, so that's how we find, all right, that is how we find our horizontal asymptotes when we're not in HK form. All right, that is how we do that. So we're just going to do 3 problems real quick here, all right, just to kind of emphasize that right here with our whole class practice. All right, so let's look at f of x, all right, in problem 1 there. So now when I look at this, right, I have a first-degree polynomial over a first-degree polynomial. So I'm in situation 2. The degree of the numerator is equal to the degree of the denominator. So I know I'm going to get a horizontal asymptote, and it's going to be the ratio of those leading coefficients. Well, the ratio of my leading coefficients would be 3 to 3, and 3 to 3 reduces to 1. So my horizontal asymptote would be y equals 1. And it's that easy, right? But it's a recognition thing. So if you don't have the recognition, then it's super hard because there's no workaround. All right, let's look at g of x in number 2. All right, I have a 0 degree divided by a second degree polynomial. The degree of the denominator is bigger than the degree of the numerator. So it's going to outgrow the numerator. So now we're in situation 3. All right, the degree of the numerator is less than the degree of the denominator. All right, which means we're going to get a horizontal asymptote, and it's going to be y equals 0. All right, and to wrap up our work for today, let's look at number 3 here. All right, I've got a second degree polynomial over a second degree polynomial. So we're back into situation 2. The degree of the numerator is equal to the degree of the denominator. So we want to look at the ratio of those leading coefficients. And the ratio of my leading coefficients is 1 to negative 3. All right, that is in lowest terms. So that means my horizontal asymptote will be y equals negative 1/3. All right, so the other piece we didn't get to are intercepts. All right, we'll cover those in class when we go through the rest of the lesson. All right, but that was really the big piece now. All right, was how do we find those horizontal asymptotes? Hopefully you feel comfortable with it, and if not, we'll hit it a little bit more in the lessons in class. All right, do your video check-in, and I will see you guys next time.